Hello, thank you very much for that introduction. And to give you some reciprocity, one of the reasons I'm up here on the stage is because Martin basically pushed me up on stage with the London Java community and said, you should do talks. And I was like, I don't think I'm ready for that. And he said, do it anyway. And now I do it as a job. So it's all your fault, and that's why I'm here. Yes, is boilerplate code really so bad? I'm Trisha Gee. I work for JetBrains. I'm a developer and technical advocate, Java champion, speaker, blah, blah, blah. And my job is largely to sort of stay up to date with trends in terms of Java, the JVM languages, and things like that. When I first started doing presentations about 5 years ago, the main complaint I heard, I was only coding in Java at the time, and the main complaint I heard is, oh, we all hate Java because it's full of boilerplate code. And I didn't really understand this because I was like, okay, that's fine, but you just kind of ignore it and get on with it, and your brain filters it all out, and so it's not really that big a deal. So I kind of wanted to come full circle now. I'm presenting in the, I don't know, this 5th or 6th time at KubeCon London and address this issue of, is boilerplate code really so bad? I know that here at KubeCon we have some like senior leads and CTOs and people who are very, very busy and don't want to spend all 50 minutes in this talk listening to me witter on. So the TLDR is, yes, boilerplate code is quite bad. So you can get up and leave now, and I won't mind. And you can go see Martin Thompson's talk, because he's my old boss and he always gives a good talk. So what are we really going to talk about? As I said, I'm a Java developer. I've been doing Java for over 20 years now, which is absolutely terrifying. That's kind of my world. That's the world I live in. But I do work for JetBrains, and we invented a language called Kotlin. And so I get quite a lot of exposure to Kotlin, even though I don't really code in it very much. And I do have this sort of, oh, it's terribly pretty. It's nice, it's clean syntax, it's designed to be productive, whatever that means. So I could have, the talk of this title could have been like, oh, Kotlin, it's terribly shiny. But as a Java developer, I feel a bit like I'm betraying my heritage. So it's also Java, it's not dead yet, which was the title of the Java track 3 years ago. And I want to really talk a little bit, not just about, oh, look, Kotlin's so shiny, but also be a little bit defensive of Java and say, but Java is also evolving, and Java is not the language that you learn at university. It's probably not even the language that you see in the code bases that a lot of you are working in, particularly these large organizations. Java has moved on a long way, particularly in the last 3 years or so. And so I kind of want to recap some of the functionality that's come in the last couple of releases that make your lives easier, but also have a sneak peek at some of the functionality from Java 10 and onwards that might make our lives easier as developers. So there's a sort of two-pronged attack to this talk. Kotlin is terribly pretty, and Java is not as bad as you thought it was, apart from when it is. This is Java. The yellowish code, the yellowish highlights are bits of boilerplate, stuff you don't really need. So like every single semicolon, the new keyword, finals, should final really be there, casting, types, information on both sides of the equal sign. And you can sort of get the feeling from this that, yes, this is a long method. Yes, this is fairly complicated looking code. But it's difficult to tell without doing a pass-through like this. It's difficult to tell which bit of it is complicated. Is it the business logic that's complicated, or is it the syntax which is overcomplicating what you're trying to achieve? Is the syntax getting in the way of you being able to see what the code is supposed to do? And that's kind of the argument against boilerplate code. Boilerplate being the stuff that you need to put in there for the language, but isn't really adding anything in terms of what you're trying to achieve, the problem you're trying to solve, the business issue. So when I talk about boilerplate, I mean the stuff that you shouldn't really have to think about because it's just there to tell the compiler or the computer to do something, and it's nothing to do with the problem that you're actually solving. But of course, I work for JetBrains. I work mostly with IntelliJ IDEA, which is obviously my favorite IDE and is amazing. Who's using IntelliJ IDEA? Oh, I love all of you. Who's not using IntelliJ IDEA but isn't coding in Java, so it's okay? Okay, then you're forgiven, that's fine. So your IDE will save you. And this was, again, a justification I gave to myself even before I started working at JetBrains. I don't need to worry about boilerplate code because my IDE will both generate code for me and also collapse stuff down so that I don't need to see it if it's not important. So the tool will help me. It will hide away a lot of this complexity. I remember seeing Dan North's talk a couple of years ago saying, well, that's all well and good, but really your tool shouldn't be the thing saving you from the language. You shouldn't have to use a big tool like IntelliJ IDEA just to write code. And of course, I disagreed with him because, Java. But you could argue that being expressive and having the ability to generate and hide away code and see stuff when you need it might be better than being so terse that you can't understand the code. I mean, how many times have you written some well-optimized piece of code and come back to it and gone, I don't know what this does. Like, I've got variable names which are a single letter. I've got some, I don't know, Perl thing which is a tiny... Being expressive is arguably better, especially if you can perhaps hide that stuff away. So maybe we can explore that idea. Modern languages generally have worked on trying to reduce the unnecessary syntax. So semicolons and type information on both sides of the equal sign, things like this. And by modern languages, I mean languages like Kotlin and Groovy and a bunch of other things that I don't really use that much. And the point here is that if you remove the unnecessary syntax, the stuff that tells the compiler and the computer what to do, the stuff that's left is the business logic. The stuff that you're reading, when you come back to the code later, is the thing that it's supposed to be doing. And of course, as developers, although we often forget this, we are reading code way, way, way more than we're writing code. I mean, when you're trying to track down that difficult bug and it takes you 2 days to track down the bug, and then it's a one line or one character fix, it's not the typing that stopped you finding that bug or took the time in fixing that bug. It was the reading and understanding of the code. So the movement in modern languages has been to remove a lot of the rubbish that you just don't need. So you only see the business logic. And when I talk about modern languages, I am including modern Java in this, so anything sort of post-Java 8, really. So Java is kind of moving with the times with this. It has the benefit, if you like, of being able to look at other languages like Kotlin, like Scala, like Groovy, and other languages that aren't JVM languages, figure out what's working for developers, what will work in the Java world, and bring that into Java the language. So it's not just stuck in the world that we learned when we learned Java 1.2 or whatever. So Java has the benefit of being able to take those features and put them back into the language if it makes sense. And we'll see some examples of this as we go forward. So let's do some code. So Martin very generously said I was very good at live coding, and I'm not going to be doing very much live coding. I'm very sorry. But for this presentation, because there's a lot of comparisons, it's actually better to have it on slideware, I think. But we will do some live coding. We will do hello world, because this is what we write every day in our business, isn't this? The infamous hello world application is we have to write this every single day. But let's do it anyway. Because this is the first thing that most people will see when they're learning your language. They're going to write a hello world language, right? So you may have seen that some universities are starting to teach JavaScript instead of Java because Java is very ceremonious, and we might have a look at why that might be. So let's create a new class. So we have to have a file called hello and a class called hello, and then we have to have the magic incantation public static void main, and then we have to have a magic incantation of system.out.println, and then we get to finally print something out to the command line. So that's 7 lines of code to print 5 characters. And that's what we mean when we talk about boilerplate code and ceremonious and a lot of ceremony around Java. Because really, all we wanted to know about was this bit. Everything else is boilerplate. It's just not important. In Kotlin, for comparison, oh, by the way, I forgot to say, I'm not a Kotlin expert. I just stole these examples off my boss. So, but they're kind of cool. And it's fun to write stuff in a different language. In Kotlin, you don't have to have a class if you don't want a class. So I can just go straight to public static void main, and I don't need to do system.out.println, and then I can say hello from Kotlin. So it's a little bit easier to get started in Kotlin, for example, and other languages. So we don't have a lot of this kind of intimidating boilerplate when we first get started with the language. This did get addressed with Java 9, and in Java 9 we have the JShell, the REPL. I'm going to open up the IntelliJ IDEA plugin to that. So now I can say system.out, oops. Oh, I actually don't even need the semicolon. Oh, she says. All right. So I can actually just go straight to prototyping with Java. You can do it inside the IDE if you want to. I think most of the IDEs support that. Or you can do it from the command prompt. Unfortunately, with high definition screens, I can't get the Windows command to actually show anything at all visible because the font size is rubbish. But you can run it from the command line. So this is not an IDE feature. This is a language feature. You can run stuff from the REPL. You can just say system.out.println, and it does it, like we used to about 40 years ago when we were writing BASIC. So that's nice. Java in particular is trying to make it a bit easier to get started with the language, to prototype stuff, to get rapid feedback without all the boilerplate ceremony. I want to have a look quickly at how we declare variables, because this is one area where we've really started to trimming out the stuff we don't need in Java specifically anymore. So in the Java 5 world, you get to say, I have a map of integer customers, new hash map, integer customer. Like, sure, I just said all of that on the other side of the equals sign. And it was a bit tedious. The IDE can help you, and it goes, well, you don't really care about the type information of hash map there because it's the same thing. And of course, in Java 7, you get the diamond operator, so you don't need to say it at all. It still applies under the covers, but the syntax means that you don't need to write that thing twice. In Kotlin, you can actually just get rid of even more. You say var. You don't need to say it's a map, because you've already said on the right-hand side that it's a map, so you don't need to say on the left-hand side that it's a map. You don't need the new keyword. This hurt my brain when I first looked at this. But it's a new map. I have to say it's a new map. But I don't have to say it's a new map because I'm using a type there. It's not a method call. So clearly, I'm going to be calling the constructor. I don't need to say new. It should just work like that. And no semicolon. Lots of people get really upset about semicolons, particularly in the JavaScript world, not surprisingly. For me, I'm like, I don't really care. I just use the magic key combination of Shift, Control, Enter, and that just fills all the stuff on the end of the line that I don't need anymore. But, you know, I guess it's really not necessary. Java 10, which is coming out in 23 days, they say, we get to say the same thing. We can say var. So we can say var, customers, new hash map. Obviously, we have to have the type information on the right-hand side there, because if you do that, you're just going to get a map of object to object, which is not of any use to anybody. So you still need the type information. But this is Java 10. So again, reducing some of the boilerplate syntax, increasing readability of the code. I feel like this might be more acceptable, possible, if you're using IDEs, because you can, when you look at customer 3 further down in the code, you can hover over it and it tells you it's a map. So I don't need to say that explicitly. I don't need to type that information. Data classes. Java beans, or simple DTOs, a simple object which has some fields and some getters and setters. This is my favorite. When I started doing live demos and I had to just create some simple files, then I started to understand why people said Java is full of boilerplate. Let's have a look. Let's create a customer. Let's make a private final int ID, private final string name, private final string email. Okay, so what I need, obviously, is I need a constructor with all of those values, because I've made them final, so they need to be in the constructor. I need, let's make that bigger. I need my getters. I need my equals and hash code. I'm not reading that, of course. Obviously, I just press enter, 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 and hope the IDE is doing the right thing. And I need a toString, because otherwise debugging is impossible. Oops. Let's try and reformat that into some useful way. So for a data class of 3 fields, I have 65 lines of code, which is kind of ridiculous, really. especially as I've just generated this stuff, and most of the time, that's what you do. You just get the IDE to generate if you're going to use those methods at all, if you're going to overwrite them. Of course, again, I can use the IDE to minimize these things, and so I can see I have those methods. I don't need to see what they are. The problem with this is not so much the fact that I have to generate code, because that's okay. I can get the IDE to do the heavy lifting. The problem is that if I generate this code, I don't know, when I come back to it later, I don't know if there's any custom code in there. I don't know whether I've overridden those methods manually, if I've done some weird magic. There's no way to tell the difference between the generated code and my own typed code. So as a developer, coming back to this code, I still have to parse all of it, even if it was generated by the IDE. And in particular, if I'm going to do something like add myself a new field, private final int age, then I have to go through and regenerate all those methods again. Or I don't do that, and my equals and hash code don't work the way I expect them to. So code generation is terribly useful, but not necessarily the answer. It's going to add an awful lot of not just steps for you to do as a developer, but cognitive load in terms of reading it. Has this been generated? Is it custom? In terms of when you modify it, remembering, oh, do I need to regenerate these things? Possibly having extra steps in your continuous integration environment to say, okay, I want you to do static analysis over these files to figure out whether you forgot to include one of these things. And this is all just kind of ridiculous for a lightweight object which only has some fields in it that is perhaps used to transform data across the wire or something like that. In a language like Kotlin, you can say, let's create a new Kotlin customer. I'm going to create a data class. Oops, not a data class. And I can say I have an int, an ID, which is an int. Maybe I have what did I say? I had a name, which is a string, and an email, which is a string. And that's it. That's all I need to do. I don't have to do anything else. Using the magic keyword data, I get the equals, hash code, toString, and getters that I expect for this class. And it's all going to work the way I expect it to. It works the same way as if I had generated those things in Java with IntelliJ IDEA. And if I want to use this class from Java, because Kotlin is fully interoperable with Java, then Java will see it that way. It will see it with those getters and setters and so forth, with those properties. I've said val here, but I could equally have said var. So if I say val, it has getters but no setters. If I say var, then it has setters as well, because it's variable as opposed to immutable. So this is one of the features in Kotlin which I first saw and thought, oh, that's quite nice. Because really that's all I want from my customer class. I want to see at a glance what is in my customer class. I don't want to see any other crap. I don't want to see any of the equals and hash code stuff. I can add behavior to this as well. So if this is a full-blown domain object, I might want to add a certain amount of behavior to it too. But then I know that any code that is in this class is behavior that I have purposefully added to this class. That's probably business logic. It's not there for the computer. It's there for me to read as a developer. And there's discussion at the moment about how to add data classes to Java. Presumably, also, should we add data classes to Java? But that discussion is ongoing. And so I've shown the Kotlin one, which makes a lot of sense to me, but that's because I haven't coded in Scala and a number of other languages, which I believe do things in a different way. So the question now is, how should we do data classes in Java? What do they look like? What compromises do we take? And what do we use them for? So they will be coming in Java version, I don't know, 100. Not Java 10, put it that way. All right, casting. This is one thing that has always annoyed me as a Java developer. If I cast something, if I do an instance of, I still have to do the cast as well. This is ridiculous. Inside those curly braces, I know that object is view, obj is view. I know that. I just said it there. So so I have to do the cast just because Java. In Kotlin, you just say, okay, inside those curly braces, it is a view. I just checked, it is a view. IntelliJ marks it as green and says this has been magically cast to a view, so you're treating it as a view now. So that's one way of doing it. In Kotlin, you can be even more concise here if you want to. Here, I've said the object coming in is basically object, it could be anything, with a question mark, which means it could also be null. So it might be coming in from Java, it might be null. And so then I can do my checking for type and calling the method with these question marks, which mean if it's null, don't fall over. And I will talk about that later. But basically, I can sort of reduce all those lines of nasty boilerplate, that's pure boilerplate code, to just one small line saying, if you're a view, do something view-like upon me. Talking of nulls, I talk much faster in London because I expect most of you to be able to listen fast in English. This is great. If you can't listen fast in English, you're doomed. I'm so sorry. Nulls. Nulls are so much fun. Nulls are so much fun that I wrote a blog post last year about how much fun nulls are not. And then lots of people disagreed with me, and they're all wrong. So in Java, for potentially, especially if you don't know the code base well or there aren't strict rules around what is null and what is not null in certain areas, you might have to do something like this, where you get a customer object in and you want to do some validation on the customer name. But first, you have to check, is the customer null? Oh, I've got ligatures turned on, by the way, which is why I've got the pretty equal, not equal sign instead of the real not equal sign. I took the screenshot, saw the ligatures and thought, I should remove that. Oh, well, never mind. You have to check if the customer is null. If the customer is not null, then I have to check, is the name null? And if the name is not null, then I can check to see if the name does something. It's a, it's a silly example, but you know what I mean. You have to do this chain of things. And I spent about an hour trying to convert this into Java 8's optional syntax because I've been trying to get to grips with optionals since Java 8 came out, and I still don't really, and I do it again and again, I still don't really grok it. This works, I have a test to prove this works. I don't really know if this is the idiomatic way of doing it, but there are no if statements in there, which is the important thing. So I can do a flat map filter if present. Then I have to have a separate method which is called throw security exception, because you can't throw an exception inside the lambda, which I don't think I knew. Anyway, so that's the optional way of doing stuff, which is pretty, but I don't think I would argue for that being more readable. I mean, the other one has 3 ifs in, which is a little bit nasty, but at least you know what the if statements are doing. You can follow that logic. As soon as someone throws in a flat map, I'm sort of lost, I must admit. The Kotlin way of doing it is, well, the real Kotlin way of doing it is to say, no nulls, none. It's never null. No, 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 which is my way of doing things as well, so I agree with it. So you just literally say, you can do customer.name.starts with, knowing perfectly well it is never null. You don't have to mess around with any of that nonsense, hence the topic of my blog post that everyone disagreed with. However, if the object coming in is perhaps a Java object or perhaps has been allowed to have nulls because reasons, you put a question mark on it saying this is allowed to be null, and then you can do your customer question mark, name question mark, starts with, and that says, look, if it's null, just don't carry on any further than this. So you can do all of that kind of logic in one line. And even though I'm not familiar with the syntax at all, and I haven't used a lot of Kotlin, I think this is much more readable. I just know that the business logic says, if there's a name and it begins with A, this is what happens. I don't have to parse out the fact that the first 2 if statements are around the stupidity of nulls, and the second one is the business logic. The third one is the business logic. This one just says, look, that's how you deal with it. Just get on with it. Switch statements. Oh, I love switch statements so much. That's a lie. Switch statements. I thought switch was a silly example to go for because I kind of thought no one programs with switch statements because we're not living in the 80s or 90s anymore. This is ridiculous. But then I remembered that, of course, we don't have control over all of our domains. Sometimes at the edges, we're looking at user input, or we're looking at stuff which comes off the wire, or we have to do some parsing of something which we don't control. And we often use switch statements for that sort of thing. So in this example, I'm going to get some port number. In this case, I've said, oh, wait a minute. I'll try not to give away stuff. The port number is coming in as a string, so I have to turn this into an integer, and then I want ultimately to get some sort of port type out of this, so I have to create a variable which is called port type, which has to be variable because I'm going to assign something to it inside the switch. It can't be immutable. And then I have to go through, and even if I've got two values which return the same type, so HTTP, I still have to list each one of these values inside my switch statement. I haven't even mentioned the fact that you've got break in there, which is just the most ugly thing in your code ever. And then if you've got any logic which is even slightly more complicated than check it against some constant value, it all has to go in the default block, in which case you're like, well, what am I using a switch for? This is completely pointless. So this is my statement in Java, and this is my when statement in Kotlin. And I can do things like, I can assign the return type, if you like, of the when to a non-variable value. So it can't be reassigned later. I know that's safe. I can do things like, I can check for a number of different values, discrete values, and assign it to some value. I can look at ranges, and I can do things like check types and things like that. And I can do all of that in here, and when I'm reading this, I can pretty much see the business logic of what I'm trying to achieve. If it's not an integer value, it's just not valid. If it's one of these things, then go off and do this. And I don't have to wade through all of the syntax, which is really nothing to do with the business logic. I might not only finish on time, I might even have time for questions. This has never happened. Default parameter, what time am I finishing? I'm going through so fast. I'm going to speak slower. Default parameter values. Lots of people ask me, especially if they come in from a different language, like how do I manage default parameter values in Java? And I say, what? Because I don't know what that means. Because we use method overloading for this sort of thing. So my default values are, never mind. Forget you ever saw that. So in order to assign default values for the prefix and the suffix, I'm just going to have a method which takes, oh, go away, they're so keen. Print message, which takes a message, and then I assign my default values here, and then I have to have like various different combinations of my parameters and assign those. And then, of course, when I'm using this method, when I'm drilling in from my IDE and I end up here, then I have to drill down to this one and figure out what that does. And it's quite difficult to get to the root method to figure out what am I actually trying to do here. In Kotlin, you can actually just assign your default values there. And you can see that in the method signature. So it's quite self-documenting. So if you don't pass in a prefix or a suffix, you will automatically get the empty string as your prefix and suffix. So that's quite descriptive. On top of that, you get the nice syntax for putting stuff into strings. Like, I didn't look up what that's called in Kotlin, but in Groovy, it's the G strings, I think. So you can actually just put the named parameters in there. So then when you're reading that, you know exactly which order those parameters come in. Whereas in the Java version, you've got S, 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 and then you have to sort of parse that in your brain. It's a bit more complicated to read that. Also, can anyone spot the deliberate bug? Right, exactly. Prefix, message, and suffix are the wrong way around. So here, I got a message and a prefix, and I'm passing into the next method prefix and message when it's actually message and prefix. So method overloading, particularly if you're talking about the same types, which we are here, is prone to these sorts of subtle bugs that obviously the compiler's not going to pick that up, so you need tests to pick that sort of thing up. Whereas when you have a single method with some default values, it's much clearer what's actually going on under the covers. So not only is it more readable, it's actually less prone to subtle bugs. So I asked Stack Overflow, how do I do default parameters in Java? And it said, use varargs. Don't use varargs, that's a stupid idea. This is not the same thing. This is basically like, just print out the random set of strings that you pass me. There's no point using a type-safe language when you're going to do something like this, because you've just passed in a whole list of I don't know what, and you've got to print I don't know what. So don't use varargs, it's silly. Ranges. Lucky for us, in Java 8, we got the ability to create infinite or finite ranges using streams. So I can say, maybe I want a range from 1 to 100, inclusive or exclusive. I can't remember which way around it works. There's a range and there's a range. I don't know. But anyway, you can do that in Java. So you get a stream of numbers. In Kotlin, you have nice, pretty syntax. I think that's the same in Groovy as well. You have nice, pretty syntax. It's quite readable. My numbers are 1 to 100, so that's nice. Java 8 is kind of, I'm cheating by using the local variable type inference thing by putting var on the front and also using static imports to get rid of the second int stream. So I would say Java 10 is nearly at Kotlin levels of readability and succinctness there. My boss doesn't agree, but then he likes Kotlin, so he's biased. Moving on from the ranges. Ranges are kind of fine. Of course, ranges pre-Java 8, you're kind of screwed. You've just got to use a for loop or nothing, I think. Moving on to collections, though, I think this is an area where Java's really evolving and changing quite quickly, and this is super useful because I've been using collections a lot in a lot of my coding over forever, and simple things can really help the way that we work when we're creating and manipulating collections. So let's say we create a list of customers. This might be the Java way of doing stuff. I was doing this like up until last September, actually. This is how I create my immutable list. It turns out that this list is not immutable at all. You can't add to it, but you can change the values in the list if you use arrays.asList. We tend not to, but you can. What you really wanted to do was have an unmodifiable list, as list of that, and then it starts to get really quite ugly. Java 9 comes in, saves the day, and you can say list.of, and you get an immutable list. That's great. Not only is that fewer characters than arrays.asList, but it actually does what you thought it was going to do, and it applies to maps and to sets as well. So this is, in my mind, this is the most useful feature of Java 9. Jigsaw is obviously amazing, Mark, if you're watching this, but this is much more useful for developers. In Kotlin, you say something similar. You can just say list of, and Java 10, again, I'm cheating by using var, but also by using static imports. So we are starting to see that the evolution of Java is making the everyday things that we do just that little bit more readable, that bit easier for us to do. It's just little things, because really the top one with the unmodifiable list as list, it's a bit icky. We just kind of live with it, but it's a bit icky. Now we get to lambda expressions, which Java was a little bit late to the party with lambda expressions, but we did have closures all along. We all used anonymous inner classes all the time, didn't we? No, because it's ugly, right? The only thing you really care about in this is the fact that you've got an event and that this is what you want to do with it when you get the event. The other stuff is literally boilerplate. It means nothing. So in Java 8, we got lambda expressions. It's purposefully going off the edge of the page because, like, you know what that's going to say. But all we do with the lambda expression is we take the stuff we really care about, the business logic, and inject that in. So in this case, hang it onto the button as the thing to do when the button gets pushed. Kotlin kind of has lambdas, has always had lambdas as like a first-class citizen. So, and it does it in a more, I think it's more similar to Groovy. So you don't need to have your little arrow. And if you notice here, I don't use the event parameter here. So I have to put it in Java, but in Kotlin, I don't need to say event because I'm not using it. And I don't need the arrow, and I don't need round braces. I just need the curly braces to say this is the behavior I want you to hang on to the button. In Java Future, 11, 12, I'm not sure, we will probably be getting this underscore to say, I don't care about this parameter. I'm not going to use it. So it just allows you to sort of hide it away a little bit. It's still there. It's not like Kotlin where you just ignore it. It's still there, but you just use the underscore to say, I don't care about that anymore. Oh yeah, there you go. Functional parameters. So talking about lambda expressions, here is the bit where, when I was learning about Java 8, I was really tripping up over this. It's one thing to write a lambda expression and to call a method with a lambda expression. So looking at the top there, here where we are doing, can you see my mouse? Not really. I've got a method called get, and I'm going to pass in a lambda expression which takes a request and a response and does something with that request and response, for example. And that's okay. I can call methods with lambda expressions. I kind of get that. But when I'm writing a method that's designed to take a lambda expression, I'm a bit more lost because it's kind of not clear to me. So one way of doing it in this case is my second parameter could be an interface called root handler. I define my interface called root handler. I tag it with functional interface to say this has a single abstract method, which means that you can override this by using a lambda expression. And then I put the signature of my single abstract method, and then that is the thing that I'm overriding when I write my lambda expression. To be honest, I'm really not surprised that I didn't understand lambda expressions when I first learned about them, because that's a lot of code to understand what's going on here. Slightly more idiomatic way of doing this would be to use the built-in by consumer instead. So instead of writing my own functional interface, I use a built-in functional interface called by consumer. This, and then it's got two types. So the two types in my case are a request and a response. And the consumer has two values which go in and nothing which comes out, which means that I can use my lambda expression, which looks like this. But then this is kind of, in some ways, although this is easier to write, this is more difficult to read, because I'm like, well, which bit of this method, this get method, says that this second parameter is a lambda expression? You can drill in and see that by consumer is a functional interface, and then you have to know functional interfaces could be represented as a lambda expression. But it's not at all obvious, especially when your autocomplete pops up on your IDE and it says, now I want a by consumer. You're like, I don't know what that is. What does that mean? So it's a bit more difficult to understand in the Java world how, when you're looking at the signature of a method, that it might take a lambda expression. And in Kotlin, this is solved by saying, why don't we express this as a lambda expression? So here, my handler is a request, a response, and it returns unit, which is like null, a void. So when I look at that method, I know that I'm going to call it with a lambda. And it's just a little bit, it's a lot less sort of thinking and working through the code and figuring out what that type is and what the lambda expression looks like. It's much more readable. And when I was looking at this example, I stole this example from the boss. I reused from within my team. I reused some code. And I just didn't really understand what this example was getting at until I realized, no, that's in the signature of the method. It's just expressing it in the signature of the method. It's just much more readable. Oh, yes, that's what I'm talking about. The sort of companion thing with lambda expressions in Java is, of course, the Streams API. So we're using the Streams API to navigate collections. So now in Java 8, we can, for example, filter all our customers for customers whose name starts with A, get their email address, and collect it into a new list of email addresses. And this is so much more readable. It's so much more readable if you know what filter means, if you know what map means. If you know what those things do, it is more readable, but only once you've learnt what that means. Because when I came to this, I've only been doing Java. I haven't used other idioms, other ways of programming. And I still don't really understand what map means. I don't know what a map is. I thought that was how you get from one place to another using Google Maps. So let me show you what this would have been like pre-Java 8. Let's look for collections. So pre-Java 8, I would have my for loop, which goes over my customers, my if statement, which is my filter, and then the customer.getEmail is effectively the map operation, and then I have to chuck that into a new list of emails. And that's the equivalent. For us long-term Java people, you might argue that that's actually more readable, because I know what a for loop does, I know what the if statement is doing, I know what's happening there. So it's taking me a little while to realize that this can actually be expressed as a Java 8 stream. Obviously, I can get my IDE to do that for me, so I'm like, great, I don't know what that means, but the IDE says that's right, so it must work. Compiles, ship it. Oops, not that. In Kotlin, you could use this syntax which gets rid of the stream and the collect, so I'm filtering and I'm mapping. It takes a customer, the filter takes a customer, checks whether it starts with A, and then the map takes a customer and returns a customer email. In fact, you can actually simplify this even further because you only have one parameter going into the lambda expression, and you're only looking at that one parameter. So you can just say it, the thing that I get, get the name, and then the thing that I get the email. There's no method references in here. It's just it's a different way of working. So it's a little bit, I think that's a little bit simpler, marginally more readable, again, if you understand what filter and map is supposed to do. But this is actually not the same thing as the Java 8 streams operation, even though it looks the same with boilerplate removed. If you want to do the same thing as the Java 8 streams operation, it looks suspiciously like the Java 8 streams operation. Because what you need to do, what streams do, which is really cool, is they're all lazily evaluated. So you start with a stream, you give it a series of instructions for your recipe, and then at the end you call a terminator, and only at that point do you go away and do the thing. So you do it all in one pass, which means you need the terminator to say, go off and do this thing, or this series of things. With the second Kotlin example, when you do customers.filter, it goes away and filters out all the customers that begin with A and gives you that list, and then you call map and it goes away and gives you a list of all the emails. Whereas the streams doesn't. It goes, oh, I'll do this all in one operation. So to do it in one operation, you need more boilerplate. So in this case, although the as sequence and the to list in the Kotlin example look like boilerplate, they're not. This is code that is necessary to tell it how to do things in the way that you want to do it. If you want to do it in one pass with a lazy operation, you need to do that. So it's important to start to understand that sometimes the code obviously is trying to tell you something important. It's not always something that you can just throw away and say, I don't need this, I don't need this, I don't need this. As always with this sort of thing, obviously there's a performance difference between the eager one and the lazy one, but as always, if you care that much, measure the performance first, because I bet you any money it doesn't matter that much, especially if you have a list of like 10 customers. I'm fairly certain it makes no difference, in which case, sure, use the more succinct one, which is more readable, and you don't care. But if you've got like, I don't know, 1 million customers, and it's a difficult operation that you're doing in the filter and the map, then maybe you want to do that in a lazy way. Oh, my goodness me. We're at the end, who knew? In summary, that's a lot of code. So this presentation is basically, well, a lot of my presentations are about code, but basically I just fling loads of code at you and say, isn't that more readable or isn't that less readable? So let's have a think about what we've learned. The boilerplate, as in the stuff you really don't care about, repetition, stuff that the compiler needs to know about or the computer needs to know about that you don't, can obscure the real business logic. So all that stuff, for example, about null checking is not really business logic. That's just crap that needs to be there to make sure it doesn't fall over in a heap. And that's what I mean by boilerplate. And it can hide away what the code is really doing. And as developers, we are supposed to be reading code. We will be reading code more than writing code. So we really would like to get rid of all of the stuff that doesn't matter, all of the stuff that isn't anything to do with what the code is really trying to achieve. The modern languages are designed to remove boilerplate, including Java is actually evolving to try and get rid of some of this stuff. And I have found that working with Kotlin, not as a non-Kotlin expert, I actually quite like working with reading Kotlin because it just gets rid of fraff, which is to do with a compiler, and just tells you what you're trying to achieve. And so it's actually, even for someone who doesn't work with Kotlin, it becomes more readable. So modern languages like Kotlin, like modern Java, has removed boilerplate, and therefore probably the code is more readable. However, readability is objective. So I've kind of talked about this a little bit in terms of like the Streams API. The Streams API is terribly readable and a lot shorter if you know what the Streams API is doing. If you don't really understand what a filter operation is, what a map operation is, what flat map is, for goodness sake, flat map, getting your head around flat map. It's much more complicated than parsing a for loop with an if statement inside it. We can kind of understand that. So readability is going to be objective from the point of view of your team. So Java developers who've been doing Java for a long time are going to have a different idea about readability to JavaScript developers, to new developers, to polyglot developers who are moving around between languages. So the purpose of this presentation is not to say necessarily, go away, rewrite your whole code base in Kotlin or in Java 10 because it'll be much more readable and you'll be much more productive, because that might not be the case. It's going to depend a lot upon the team that you're working with. All the information from this talk is available on this URL, or probably will be in the next 5 minutes. I've got the slides and loads of links to all the features that I talk about, the Java 10 features, the features which are coming up in the future, the Kotlin features I've used. They're all, I've got links to all of them in there. So I didn't want to go into each of the features in a lot of detail. I just wanted to show you what it looks like to read. So if you're interested in any of them, they're all available on this URL. Thank you very much.